Hey everybody, so today we're going to look at basic collections in Python. In a future video, this will be like advanced collections. We'll take a look at default dictionaries, ordered dictionaries, index, and I think there's a couple others like name, tuple, and maybe some others that we'll look at in a future video. But for this one, we're just going to focus on lists, tuples, sets, and dictionaries. We're going to go through some things, just different things you can add to each of these collections, different things or different functions or methods you can run on these collections. And then at the end of this, and you can just skip to the end if you just want to see the resources, but there's a list of all the different methods you can run on lists, sets, and dictionaries. Tuples are a little bit different because you can't do much with those. They're kind of like a set thing. So, but for the others, there's a whole bunch of different methods you can run against them, and I'll share that at the end. All right, so the first thing we're going to look at is a list. A list is a mutable sequence of values. This is the list function, so this will return a empty list. And then what we're going to do is just, we're going to print that list. We're going to print the type to make sure it's a list. And then this is just going to check if the list has anything in it. If it doesn't, it returns false. So I'll do Shift Enter. You'll see we have an empty list. That's what we see here in the brackets. And then we have a list class and false. Now here's a list of items. So we have a list of strings. We can put strings in there. We can put nums and strings, or doubles and strings, which I don't have doubles represented here, but you can put pretty much anything you want inside of a list. Here's a list of vars, or variables and collections. So we have strings, we have ints, we have tuples, dictionaries, and even sets inside of this. We can also have another list inside of this as well. So I can just do a comma and then just add the list. So now we have a list inside of that list, along with all the different other collection types and items or variables. So here, so I'm going to run this one, and so now we have all these variables assigned the different lists. So we've created 3 variables with 3 different lists and the collections inside of them. And this one's just going to check that last one. So list of vars and collections. So if we run that, you can see it's a list. And actually, I want to point out something too. So mentioning variables. So if let's just say we have var1, we can go and add that as well to this. And then you can see this will return a list. That's what this is. And then just to see kind of what's going on, what we can do is loop through that list and then quickly see what type everything is inside of that list. So you can see we have a string, we have an int, we have a tuple, dictionary, set, list, and then for this one it returns the value of that variable, which is a int. So there you go, each of those items inside of that list. You could do list of lists. I'm sure if you've watched my other videos, or if you are watching things on this channel, you're probably familiar with Dynamo. List, you can do lots of list of list. So that's exactly what this is. So L equals a list with multiple lists inside of it. We can get items at index just like we could in Dynamo. So we'll do the list. We've got 2 items here, and then what we can do is L and then the index value. And then it returns item 3. We can update an item at the index. So again, with 1, we're going to change that to item 2. And then this L is going to return item 1. We don't have to print, so I don't have to do this. So if I rerun this block, you'll see it outputs the same thing. In Jupyter Notebooks, you can just put the variable there, and it'll dump out the return of that, or what is inside that variable. So I just wanted to point that out. So now what we can do is append to that list item 3. So we do l.append. We can go through and append a list, so we can take another list and append it. And I wanted to show you this to kind of see what happens. So if we do it this way, and maybe this isn't the result we wanted to actually add those items to that list and just keep one list, the append will actually append that list into this list. So you're going to get item 1, 2, 3, and then list with item 4 and 5. To actually just bring in the items inside of that list, what we can do is do the extend method, which will return or actually pull those items into the list and extend it. So now we've got all our items from 1 to 5. Slicing, if you've used Dynamo, there's a slicing node, same thing. So you can see here we return item 2 and 3. List comprehension, I think, is a more advanced topic, but as far as I know and the way that I've used it, it's like if it's too much to go like for I in whatever, do this, what you can do is keep it as one line. And I'll have to take a look at the PEP 8 documentation to dive a little bit more into when and when not to use list comprehensions. But I just wanted to point out this is a nice clean way to quickly loop through something. So in this, you can see if we run it, it'll times everything by 2, so we've got 1, 14, 18, negative 10, 4, negative 18. Also, one other thing I want to point out before we move into tuples is that that lists are unordered, so there's no particular order. Sorry, let me correct that real quick. It is ordered in the sense that the items don't they don't move, so the placement is preserved. And that's different than like a set, which we'll look at a set later, but this would be a set here. And so if we do, let's do 1, 0, we'll do 2, 3, 5, 4. So something like this, and if we run this, and you'll see that it returns an ordered, or kind of the order doesn't matter. So this would qualify as like an unordered list, and it qualifies as an unordered list because it doesn't preserve the location where things are like a list. So if you create a list, and we can do the exact same thing. And then you'll see it'll just keep the order of that list. So I just wanted to point that out because sets, the lists are ordered, and then tuples are ordered, sets aren't. So anyways, let's move on to tuples. So tuples are fixed sequences of values, just like lists. Pretty much the same thing. The thing you can't do with tuples is really you can't modify them. There are a few methods you can actually run on a tuple, and the two are the count method and the index method. And at the end of this, there will be a resource I'll post. I haven't added it to the end, but it will be there when you actually, if you download this tuple. But if you just search for tuple methods, you can see those two methods. Anyways, this is our tuple. Just like we did before, we're going to print the tuple, and you can see it here. And then you can see the class is tuple, and it's empty currently. And just like we did with the list, we have tuple. Just like we did here, this will create pretty much an empty tuple. This isn't a big deal, but what's interesting is if you want to create like an empty set, which we'll look at that later, this would be the route to do it because sets will default to a dictionary otherwise. So to create an empty tuple, you would put this in. So now we're going to look at tuples of items. Tuples are a little bit more limited with what can be in them. Or sorry, that's sets. Let's just run this, and then we'll take a look at the different collection types in there. So if we check the type, you can see it's a tuple now for that tuple of vars and collections. And now we're going to loop through that tuple. We can loop through it and kind of check stuff. So you can see we've got string, tuple, list, and sets. So pretty much anything could be inside a tuple. Just like a list, sets are a little bit more limited in what they can actually have inside of them. Just like lists, we can have tuple of tuples. We can return an item at a specific index. And you can see here we can't update it. So again, there's no modifying a tuple. And so that's why we get this error. We can return a slice of a tuple. Actually, this is wrong. Let me rerun this. So we can return a slice of a tuple. And you can see that if we check the type, it does return a tuple. So it is a separate item. It's not modifying the original tuple. So if we actually run that T, you can see that it's untouched. It never went in there and modified it. So list comprehension using a tuple, just like what we saw before, we can run this on a tuple. It doesn't modify the original one, but what it does is it takes it, turns it into a list pretty much, and then runs through it and prints the values. So if we run through that, you can see it returns the values. And if we do the same thing we did above, you can see it runs through the list of tuples, which is this now, times everything by 2, and then returns it back as a list. So tuples are, you can't modify them, and there's not many methods you can use, but what you can do is convert tuples to a list, and then use all the different methods that you could use on a list on a tuple. So in this, what we're doing is we have our tuple here, and we have this list, and what it's doing here is we're using the list method to turn that tuple into a list. We're appending 10 to that new list, and then we're converting that list back into a tuple. So at the end of this, we're going to get this tuple returned with 10 at the end of it. And so if I run that, you can see the result. So we still have a tuple, and it's modified, and that this one doesn't exist anymore. It never actually modified it, but what we did was we converted it to a list, which we then modified, and then converted it back to a tuple, and then gave it the same variable name. And so now we have an updated tuple. Now, for whatever reason, if you're coding and you need to do that, that would be the method to do it. But I would expect that if you're using a tuple, you probably don't want it to be modified at all, but maybe you want items to be added or something. This could be a good method to go about it. All right, so sets. Sets are kind of interesting, and I don't have a... or actually, I wanted to point this out before we look specifically at sets. So if we run that, you can see it returns a dictionary. And that's because by default, when you do the curly braces, it'll just default to a dictionary. And so you'll need to do the set method if you actually want it to return an empty set. So if we run this, you'll see it's dictionary, but if we run this, we'll get a set, and then the class is a set, and then does that set have anything in it? False. So set of items. I kind of mentioned above when going through tuples, sets are a little bit more limited in what they can actually have inside of them. They can't really have other sets. So if we do add a set to this, you'll see we'll get an error. So they are limited in what type of items they have in it. I want to point out real quick, a collection of unique items. That's what a set is. And we'll look at that when we pass through different values and what it does to them. And so if we run this, and let me fix this real quick, you'll see that we have item 1, 2, 3, 2, 3, 4. So there's a total of 6 items in this set. Currently they're all strings, and you'll see that when we print that variable, so that's set of strings, that's this one here, we get a return of 4 items because it removes pretty much all those non-unique items and it only returns the unique ones. So only returns the unique items of that set, gets rid of everything else. And let's check this set real quick, and we can see that the set of vars in collection returns a set. Let me remove this real quick because this isn't supposed to, well, actually, I wanted to, okay, so this is dictionary to set. I got confused for a minute. I thought this was supposed to be in the dictionary portion of this, but so we've got dictionary to set. So we've got our key value, and we'll look at dictionaries in a little bit, but pretty much a dictionary is a pair of keys and values. You use the keys, you can use a key to call on the dictionary, and it will return a specific value that matches that key. And so, like, here we have dictionary 1 with key 1, value 1, key 2, value 2. And we have an empty set, so we're just creating an empty set, and then we're going to set dictionary equals empty set dot union. All this is doing is it's returning all our values as a set. So at the end of this, we're going to get a set. This empty set isn't going to be empty anymore. It's actually going to have stuff in it. It's just going to have the values returned. Or sorry, the keys returned. So we're going to get our key 1, key 2. So we're going to have a list or a set of key values returned from that dictionary. And that's there's many different methods you can use with sets. And again, at the end of this, we'll look at that. So looping through a set and printing the types. So if we run through that, you can see inside of the set above, this one here, that we've got integers, tuples, and strings. And here, what we're doing is we're going to return the intersection of two sets. So we've got set 1, 2. We're going to do set 1 underscore set 2 equals set 1 intersection set 2. If we run that, you can see we've got 2 and 3. This one's going to check the difference between the first list and the other list. And so the difference between this one and that one is 0 and 1. And if we flip that around, it'll show the difference between S2 and S1. And so it returns -1, 4, and 5. Now, if we want to join the sets, and so we can join like 0, 1, 2, 3, and then 0, 1, 2, 4, and since they have only one unique, or since S2 only has one unique value, it joins, and then you have 0, 1, 2, 3, 4. And that's pretty much what's going to happen. So if we do this, you can see it goes -1, 0, 1, 2, 3, 4, 5. And you can see here none of the duplicates were added. So 2 and 3 were dropped, and the only things were kept was 0 or -1, 0, 1, and then 2, 3, 4. So again, it's just joining them, and then any of the values that are doubled up, it just gets rid of them and keeps just one of them. So you can see a set is ordered, so it'll go through the lowest to the highest. Here, I'm kind of confused on what the heck is happening. I call this set comprehension, but I'm not totally sure if that's what it's called. We're doing the same thing we did with the list. We're looping through, but if you see the return value, it's kind of confusing. So it did double everything like it should, but the order is a bit confusing. And I'm sure if we actually looped through this and appended it to a new set, it would order correctly. And because we're looping through it and multiplying stuff, there's an issue when it prints. I don't know. I'm not totally sure what's going on here, but it's interesting. I wanted to share it, that we can do this. But anybody who has information, feel free to comment. But at a later point, when I get into list comprehension, I'll try to dive into this and figure out what's going on. So now dictionaries. Dictionaries are my favorite. I've used dictionaries so many times in different Python scripts and different Dynamo scripts, and I absolutely love them. So dictionaries are a collection of key values and pairs. I think they're really powerful too for your application. They allow you to do some really cool stuff. So hopefully, if you didn't know dictionaries, hopefully this kind of gives you an overview of how to use them. For the most part, they're not that difficult. So we've got our dictionary here, and we've got the dictionary method, which is going to return an empty dictionary, and we're just going to check the type. So if we run this, you can see we've got a dictionary. So now we've got the same thing we've seen before with tuples, sets, and lists, is we're going to have a dictionary with different items. So the first value or item in the dictionary would be the key, and then the second part of it would be the key, or the key values, the value of that specific key. And then comma separated, we have a new entry, and then our third one. And so here we've got dictionary numbers and strings. So we've got key 1, 2, 3. We've got integers, and then a string. And then down here we've got variables and collections. So we've got a string, we've got an int, we've got a set, we've got another dictionary inside of a dictionary, we've got a tuple, and then here at the end we've got a list. So pretty much anything can go into a dictionary. So if we run this and then check the type, you can see it returns a dictionary for the dictionary of variables and collections. And so we're going to loop through that, and this is kind of interesting. If we loop through that, you'll see that we get a bunch of strings. It's because it's only returning the key values right now. But if we actually loop through this, since we know we're looping through and getting the key values, what we can do with that I is use it to get the actual values for each of those keys. So what we can do is loop through it, and we're checking the type. We're also printing it. So we're printing it, we're going to check the type, and then within that, we actually have our dictionary, and then we're doing the get method. And the get method takes a key input and then returns a value. So since we're looping through and we know this is returning the key values, what we can do here is loop through and then put that inside that get method, which is going to return the actual values. So if we run this, you'll see that we get the types for each of those values in that dictionary. So we've got a string, integer, a set, dictionary, tuple, and a list. So returning the dictionary as a list collection of tuples. So if we run this, you'll see here that it goes through and it grabs the keys and the values and puts those in a tuple, which is in a tuple. So it returns everything, or sorry, it returns it as a list, and then each of those pairs of keys and values are tuples. And then within those are the keys and values and whatever those values could be. So in this case, there's sets and there's dictionaries and there's tuples and lists. So there could be a variety of different things in that, but it returns it as sets. And what we're doing here is just running through that. You can see it. Everything in there is a tuple. So I've used this. So removing items from dictionary at key and adding the value to a new list. So this pop method, so right now we have a pop list and we just make it empty for now. And then we're gonna, and this variable, so dictionary pop, we'll actually use the pop method. So here's our dictionary, and then here's our pop method, and inside of that, when we call that method, is a key value. So in this case, we're gonna pop out tuple from the dictionary, and we're going to append that to pop list. So we're going to append this dictionary pop, which is right here, to the pop list, and then we'll print that. So you'll see here we've got the value of that entry and that dictionary entry, and if we scroll up, you'll see the tuple here, and so it returns that inside of this list. And then if we check this dictionary, you'll see that it's no longer inside of that dictionary. So anyways, that's what I got on lists, sets, tuples, and dictionaries. Just remember that list, dictionaries, and tuples are ordered, meaning that they preserve the order of the list. And sets are an unordered list. They will reorder the list and totally disregard the way that the values were inputted in the actual set. So anyways, that's what I got on these different collections, and in the future we'll dive into some more advanced collections, but before then, if you want to take a look at some of these resources, so more on lists, here's all the different methods on those lists. And if you download this Jupyter Notebook, you can actually click on this and go to the location where you can find this information. So definitely download this if you want to check out these sites, or if you just want to copy this stuff out. Python sets, so here's a bunch of different methods. Dictionaries. I definitely recommend spending some time on dictionaries and really wrapping your head around them if you don't understand them, or don't know how to use them, because I use them in a ton of different scripts of mine. A future video that I'm going to do is there's a dictionary that I'm using quite a bit throughout the script, and so look out for that video. It's going to be about masses, and you'll see at least one way to leverage dictionaries. And so, if anything, I definitely recommend checking out that collection type, because I think you'll find it pretty useful. But anyways, that's what I got for this video. Let me know if you have any questions or any questions on any of these collections. Just reach out anytime. And I appreciate you guys watching, and I'll see you in the next video. Thanks.